Alright, we're going to look at Chapter 6, Lesson 2, using models to multiply whole numbers. This is day 74. The standard is 5 MBTB 7. Go ahead and, if you haven't yet, review the standard. Go ahead and pause the video to do that. Okay. The standard says using concrete models or drawings and strategies based on place value. So for that reason, we're going to start today using two different models. The models that we're going to use are the hundredths grid and also a number line. The hundredths grid is important because that's how we started with when we with adding and subtracting decimals. So we're going to come back to that. The other thing that we have to think about right now is decimals are a special type of fraction. So when we're doing our work today, we're going to represent our thinking in both decimal form and fraction form, and that's going to be important moving forward in the rest of this unit. Some really important notes, please read this piece as you are planning your lesson, because we skipped over Chapter 6, Lesson 1 on estimating. It's round this number to the nearest whole number and multiply by 4. That's how we want students to estimate. It doesn't take a full class period to teach that. That should be done through Do Now. Here are some questions that you can use the spiral on Do Nows and homeworks. And then the other thing that, another important note is, please today, even though we're giving the assessment on Elluminate, I'd also really appreciate it if you provide students with the paper version of the exit ticket, because the aim of today is that students will be able to use models. If they're not being able to have access to these models, then they can't really practice what the aim is. So yes, give them the paper copy and also have them do the test on Elluminate. Okay, let's look at example 1. What we're going to have students do is use these models to find the product of 2/10 and 3. So we're going to do 3 groups of 2/10. So we shade in 2/10 and 2/10 and 2/10. And so we see in all that that's 6/10. So what we want students to be writing is 2/10 plus 2/10 plus 2/10. Oops, I'm writing this in the wrong spot. Here we would write 0.2 times 3 is equal to 6/10. Another way that we can have students write this is 2/10 times 3 is equal to 6/10. Okay, so 6/10 and 6/10. This is equal to 6/10. We can also use 2/10 plus 2/10 plus 2/10 is equal to 6/10. Okay, this fraction form is going to come in super helpful later on in the chapter. Let's look at the next one. Using the models to find the product of 6 times 3/10. I actually want you to take a second and think about how this work is going to be different than example 1. Okay, so when I multiply 6 times 3/10, I end up with a number that's greater than 1 whole. So we want 6 times 3/10 is equal to, then we'll shade in 3/10 and 3/10 and 3/10 and 3/10 and 3/10 and 3/10. And so that we see that this is 18/10, which is equal to 1 and 8/10. Okay, we have to regroup when we have 18/10, because 10/10 makes 1 whole, so 18/10 makes 1 whole and 8/10 left over. This is why the fraction form is so helpful. 3/10 plus 3/10 plus, I'm just going to copy this, 3/10 plus 3/10 is equal to 18/10, which is the same as 1 and 8/10, which is the same as, 1 and 8/10. Again, I wrote this in the wrong place. Times 3/10 is equal to 18/10, which is 1 and 8/10. Okay, so we can check using repeated addition with both decimals and fractions, ... Okay, now let's look at this next one. Write a multiplication sentence that is represented by the model below. Here, so we have 4/10 times 4, which again gives me 16/10. So if I'm writing a multiplication sentence, what that looks like is 4/10 times 4 equals 16/10. We can also write it as a fraction. 4/10 times 4 is equal to 16/10, which is the same as 1 6/10. And then we want students to write this using repeated addition over here, using either a decimal or a fraction, preferably both, and then answering this question. Justice wrote the following multiplication sentence. 4 times 4/10 is equal to 16/100. Explain why justice is incorrect. Use place value in your answer. So like we know that 16/100 is less than 4/10. Because 16/100 is less than 4/10, this is not a reasonable answer. Because I multiplied 4, which is a number greater than 1, by 4/10, okay? 4 times 4/10, I shouldn't have a number that's less than this original number, 4/10. The other thing that students could explain is that 16/100 is not represented in this model. You could say like 16/100 would just be one of these lines and 6 more, right? So like that would be what 16/100 is. What we're seeing here is like one whole, so 100, so like one whole is like 10/10 and 6/10 left over. Okay, let's look at this next one. Now we are using a number line. So again, we're showing this repeated. Oh, you know what? The other nice thing here is like this repeated addition, you see it in this model. You have 4 groups. This is the same as 4/10 plus 4/10 plus 4/10 plus 4/10. So when we move to a number line, it's not all that different. We're showing 3 groups of 3/10, so 3 hops, each being 3/10. This is very similar to the work that we did when we multiplied fractions and whole numbers, right? Like we showed that on a number line. We're jumping to 3/10, then we're jumping again to 6/10. That would be 3/10 times 2, and then finally 3/10 times 3. Then when we're having students answer this question, how is using a number line to show whole number and decimal multiplication similar to using a hundredths grid? Well, they both show repeated addition. I see it here in the jumps, and then I see it up here with the repeated groups, 4/10 and 4/10 and 4/10 and 4/10.